Welcome to lesson 2.8, Proving Angle Relationships. This video is going to go a little bit differently because your notes are set up just a little bit different, but you shouldn't have too much trouble following along. So previously we identified and used special pairs of angles, and now we're going to write proofs involving supplementary and complementary angles, and write proofs involving congruent and right angles. So I'm going to kind of quickly go through the list of postulates and theorems you have in your vocab. We have what we call the angle addition postulate, just like we had the segment addition postulate. It says if these two angle measures are put together when they are adjacent angles, then the sum of their measures is equal to the total. And then we have theorem 2.3. Now in your notes, it's written a little bit differently, and in your book it's written differently, but this name is a little bit better name. In your book they call it the supplement theorem. Alright, but this is more commonly known and more popularly known as the linear pair theorem. If two angles form a linear pair, then they are supplementary angles. So if we have a linear pair, we always have a pair of supplementary angles then. Then we do have the complement theorem. It says if the non-common sides of two adjacent angles form a right angle, then the angles are complementary. And then we have reflexive properties for congruence of angles. Reflexive, symmetric, and transitive properties all apply. Just like they did for equality, they also apply for congruence, congruent angles as well as congruent segments. We have the congruent supplements theorem. Now it tells you the abbreviation you could use in as a reason in a proof. We can actually just call this the congruent supplements theorem. Same thing with congruent complements theorem. We can use those proper names as a reason in a proof. And so here's what it says. Congruent supplements theorem. If we have angles that are supplementary to the same angle or to congruent angles, then they have to be congruent. So if we know that 1 and 2 are supplementary and 3 and 2 are supplementary, 1 and 3 have to be the same measure, so they have to be congruent. Same thing with complementary. If we have two angles that are both complementary to the same angle, okay, 4 and 5 would make a right angle, 5 and 6 would also make a right angle. That means these two have to be equal because they use the same value as their complement. We also have the vertical angles theorem. Vertical angles are always congruent. So 1 and 3 are vertical angles, they have to be congruent. Same thing with 2 and 4. And lastly, we do have some right angle theorems. Let's quickly go through these. Perpendicular lines intersect to form 4 right angles. So if you know that lines are perpendicular, you know that these are right angles by the theorem 2.9. All right angles are congruent. We call this the right angle congruence theorem. That's how you could abbreviate it and use it in a proof. Perpendicular lines form congruent adjacent angles. Okay, so 1 and 2 are congruent because they're right angles. They have to be congruent to one another. If two angles are congruent and supplementary, then each angle is a right angle. Congruent supplementary angles have to be right angles. If two congruent angles form a linear pair, then they are right angles. Let's take a look at example 1. Here's what we have. We have this diagram given in example 1, and in that figure, angle 1 and 4 form a linear pair. And we wouldn't have to state that as given information if you have the diagram. It can be implied from that given diagram, but they do go ahead and tell us that. And then we also know that the measure of angle 3 plus measure of angle 1 is 180 degrees. We want to prove that 3 and 4 are then congruent angles. So here's how we do this. Step 1, state all your given information. We've got angle 1 and angle 4 form a linear pair. And measure of angle 3 plus measure of angle 1 equals 180 degrees. And so we're going to talk about that given information now. If they form a linear pair, remember we have the linear pair theorem that states that 1 and 4 have to be supplementary. And if these two measures add up to 180, these two have to be supplementary. So here's what we can say. 1 and 4 are supplementary by the linear pair theorem. Remember that was the one that we also called the supplements theorem. But more often than not, I will use that as the name of it. And like we said, since the measure of angle 3 plus measure of angle 1 equals 180, that makes them supplementary just because that's what supplementary angles means. Their measures add up to 180. That's the definition of supplementary angles that tells us angle 3 and angle 1 are supplementary. We also had a theorem if you'll remember back just a few moments in the video, that says if I have two angles that are supplementary to the same angle, so 1 and 4 are linear pairs, so they're supplementary. 1 and 3 are given to us as adding up to 180, so they're supplementary. So that means 3 and 4 are both supplementary to angle 1. So when I have two angles that are supplementary to the same angle, I can say those angles are congruent by the congruent supplements theorem. All right, let's take a look at example 2. If angle 1 and angle 2 are vertical angles, and the measure of angle 1 is d minus 32, and the measure of angle 2 is expressed as 178 minus 2d, we should be able to find the measures of angles 1 and 2. Now I don't have to draw the picture here. I could draw any two vertical angles, 1 and 2. I could call the measure of angle 1 d minus 32, and the measure of angle 2 178 minus 2d. Now, they're vertical angles. You may remember that vertical angles are congruent. That means these measures are equal to one another, and that's how I can come up with an equation to find the value of d and plug it in to find the angle measure. So we're going to write that out as a proof. Our first statement is all that given information. Angle 1 and 2 are vertical angles. Measure of angle 1 is d minus 32. Measure of angle 2 is 178 minus 2d. Angle 1 would have to be congruent to angle 2 by what we call the vertical angles theorem. The theorem we just talked about a little while ago says vertical angles are always congruent. And if 1 and 2 are congruent, we know their measures are equal. Now, I do have to talk about their measures, as you'll notice from the given information. So I need to say that their measures are equal by definition of congruent angles. Now, since their measures are equal, I can substitute d minus 32 in for the measure of angle 1 and 178 minus 2d in for the measure of angle 2. And the reason is substitution. And now we just have to solve this equation. The first thing I would do is add 2d to both sides. Through the addition property of equality, we get 3d minus 32 equals 178. And then I would add 32 to both sides and get 3d equals 210. Then the next step, we're going to divide both sides by 3 to get d equals 70, so that's the division property of equality. And then we've got a couple more steps, because remember, we're supposed to be finding the measure of angles 1 and 2, so that's the end of our proof when I know the measure of angle 1 and 2 and tell what their measure is. So what I need to do now is go back to these statements and plug in 70 for d through substitution. So measure of angle 1 is 70 minus 32. Measure of angle 2 is 178 minus 2 times 70. And that's, again, substitution. And then I just have to simplify each of these to get the measure of angle 1 and the measure of angle 2 both equal 38 degrees. And your reason is simplify. So a little bit longer proof, but again, it's fairly an algebraic proof, just using our properties to find the values of d and plug back in to find the measure of the angles. Alright, let's move on to example 3. In example 3, we are given angle QPS is congruent to angle TPR. Highlight those for you. QPS, that angle, is congruent to angle TPR. And what we want to do is prove that QPR and TPS are congruent. And so here's how we're going to do that. We're going to first state the given information. We only have one given to incorporate. And that is going to end up telling me about the measures. And here's how I know that I'm going to need to talk about the angle measures, not just congruent angles. Both of these angles have angle RPS as part of them. Through the angle addition postulate, these two should total QPS, and these two should total TPR. And so I'm going to have to talk about their measures because the angle addition postulate uses measures. So I'm going to change this statement to the measure of angle QPS equals the measure of angle TPR by the definition of congruent angles. Then I can set up my angle addition postulate with these two statements. QPS is equal to this total of the measure of angle QPR plus the measure of angle RPS by the angle addition postulate, and the measure of angle TPR equals the measure of angle RPS plus the measure of angle TPS by that same reason. And what you'll notice about the right-hand side of each of these is they both share angle RPS. And you'll also notice that the measure of angle QPS equals the measure of angle TPR, so if these two are equal, then the other sides of both of these equations are equal by substitution. So I can say measure of angle QPR plus measure of angle RPS equals measure of angle RPS plus the measure of angle TPS by substitution. And once again, remember we noticed they both share the measure of angle RPS on both sides, so I can subtract that from both sides and get the measures of angles QPR and TPS are equal by the subtraction property of equality. And since these measures are equal, I can move on to what I was trying to prove, that the angles are congruent by definition. Alright, now we can move on to example 4. These next two proofs aren't very long at all. Let's look at example 4. We're given angles 4 and 3 are congruent. Go ahead and mark those on your diagram like this so that we know these are congruent. Now let's look at the figure and figure out what else we can determine to try and say that 1 and 2 are congruent. Well, 1 and 4 form a linear pair. By the linear pair theorem, they're supplementary. And then 3 and 2 also form a linear pair, so they're supplementary. So that would show me 1 and 2 are each supplementary to 3 and 4, but 3 and 4 are congruent. If you remember the congruent supplements theorem, when I have two angles that are supplementary to two other angles that are both congruent, then these have to be congruent by that theorem. So here's what we state. We start with our given. Angle 4 and angle 3 are congruent because it's given. And then we know angle 1 and angle 4 are supplementary, and 2 and 3 are supplementary by the linear pair theorem. And so what we've shown is that 1 is supplementary with 4 and 2 is supplementary with 3, which 3 and 4 are congruent angles. So by the congruent supplements theorem, angle 1 is congruent to angle 2. And that brings us to example 5. Now before we try and do example 5, look at what you're given. Angle 1 and angle 4 are congruent, that's already been marked. You want to prove 2 and 3 are congruent. Well, notice angles 1 and 2 are vertical angles, angles 3 and 4 are vertical angles. You should be able to conclude that 1 is congruent to 2 and 3 is congruent to 4. 1 and 4 are congruent. Let's see if you can find out why 2 and 3 must be congruent then. Take a few minutes to try and put this proof together, and when you think you would like to check your answer, continue watching the video. Alright, we should get this. We have our given information listed first, and we recognize vertical angles 1 and 2 and 3 and 4. So by the vertical angles theorem, 1 and 2 are congruent and 3 and 4 are congruent. Now, there's really only one thing left to do to make the jump to angles 2 and 3 are congruent. 2 is congruent to 1. 1 is congruent to 4. 4 is congruent to 3. So I can make the jump all the way from 2 being congruent through all of these over to 3 by the transitive property of congruence. Alright, that wraps up our lesson on proofs involving angle relationships. We will do some more work with this during class, but you should have enough to get started.